Good morning, Gotham. Welcome to SSN, also known as Statistical Skibidi News. My name is Kitty Trejo, and this is my co-host Santi.
Good morning, Gotham. I am one of the two Skibidi newscasters, and I'm truly excited about today's episode.
Today we honor the end of the school year, and we have bought the best special you ever see. As we know, this year has been great, and it has taught us plenty of lessons. This new special is called the Year in Review. The word Skibidi will be said a lot. If at the end of this newscast you can call the number below and tell us the right amount of times we said it, you will get a prize. So make sure to pay attention. Moving over to weather, it is well known that high temperatures in Gotham can go over 100 degrees and at the same time can go under 60 degrees. To confirm this, our research team collected the high temperatures of 366 days in Gotham for 2024. I heard the researchers were very happy to collect the temperatures of all 366 days. I think they would have been crying of happiness, of course. With the collected data, they created an amazing histogram and box plot so we could see the distribution of daily high temperatures of Gotham. Whoa, those are really nice distributions. As we can observe in the histogram and box plot, the distribution of daily high temperatures of Gotham in 2024 is skewed left. Unimoto at 90 to 100 degrees Fahrenheit has 4 outliers at 29, 36, and 41 degrees Fahrenheit and has no gaps. In addition, the distribution of daily temperatures of Gotham in 2024 has a center at 86.5 degrees Fahrenheit and a spread of 21 degrees Fahrenheit. Crazy how Gotham reached 29 degrees Fahrenheit and over 100 degrees Fahrenheit in the same year. This weather seems to not be too bad. But make sure to wear sunscreen when you go out this summer.
Wait, I'm just getting intel here at SSN Station. A question was personally asked by the billionaire Bruce Wayne, who has been to global warming of the city of Gotham in the past years. There's speculation that the one Bruce Wayne could possibly possess the identity of the one and only Batman. Let that sink in. Going back to the question, global warming has been a concern over the past years and has raised concerns about the high temperatures of Gotham. Bruce Wayne, being one of the most powerful and concerned citizens of Gotham, asked the question of whether there's evidence that the average temperature for Gotham was higher than the historical average. To ensure that we were able to generalize the whole year, we will randomly select 30 days to fulfill randomization. We will run an SRS. First, we number out the days 1 to 366, then use random int 1 to 366 to randomly select 30 days, ignoring repeats, then find the average highest temp for these 30 days. The weather we got from these 30 days were all combined and divided by 30 to get an average of 84.233 degrees Fahrenheit and a standard deviation of 16.23 degrees Fahrenheit. Now that we have our mean and standard deviation of these 30 randomly selected days, I will now run a one sample t int. My parameter is true mean daily temp for Gotham in degrees Fahrenheit, and we'll run my checks. Randomization, yes, since we ran an SRS of 30 days. 10% condition, yes, since 30 is less than 366 days or 10% of a year. Large enough, yes, since 30 is greater than or equal to 30. So by CLT, the true mean daily temp for Gotham in degrees Fahrenheit can be approximated as normal. Since my checks for inference have been met, I can now run a one sample TN. Here my calculation is not on the screen, as you can see, since the mean temperature historically in Gotham in degrees Fahrenheit is 83.724, which is contained in my interval of 77.986 degrees Fahrenheit and 90.481 degrees Fahrenheit. There is not evidence that the true mean temperature of the average and high temperature of Gotham in 2024 is greater than the historical average temperature for Gotham. Thank you to Mr. Wayne, or Batman, for this segment of weather. Now on to Kitsia, who I've heard has two very special guests.
Santi is right, but before we introduce our two amazing, super special guests, let me introduce you to Gus. This is our new co-host. He will accompany us for the rest of this newscast and will be here to help us. Now, moving on, Santi is right. We have two really amazing guests in the show today in honor of the end of the year. These really special guests have released one single, and I heard it's the best of the decade. Welcome, Kid CN and Santites, all the way from the station in the back cave. Hello, everyone. It's an honor to be here. My name is Kid CN, and this is Santites.
What's up, SSN Station? It's on T-Test here. I know you guys are used to me having 3 hats, but on the way here, the Joker stole it. I hate that guy, yo.
Dang.
But what's up?
We have to wait for Batman now to get those hats back. It's great to have two stars like you on the special today. Now tell us something about your guys' single. I heard it has become very popular amongst youngsters. Our single Entrance Yo has been doing great on the charts and it's incredible. So I really hope y'all been listening to it. We decided to write this single in honor of our stats class. We love stats and we love everything about it. We decided to talk about our 4 favorite units, which is inference, or 4 favorite units about inference, which is proportions, means, chi-square, and linear regression. We love stats so much. Those units taught us a lot. So we wanted to teach other people through music. So we decided to write about inference. I hope our single and y'all been listening to it.
Man, I love stats. I don't think kids just said it, but we got our beat and our inspiration from none other than Timothy Chalamet, the famed superstar AP Stats student. I'm so excited for what the future holds. Watch out for our next album in about 5 years that will also be on the topic of stats. Thank you.
Our single Inference Stats hit #1 in only 1 week in the full world. So please keep streaming it. It's on all platforms available. So please like, comment, subscribe, and don't forget to hit that damn bell.
Hit it, smack it. Let's go.
Put it in your pocket. Thank you, SSN. Looks like Inference Yup is really awesome. Great hearing about those two. They seem cool, especially Kidzian.
I'll have to disagree with you there. Santi Test, that's the man. Thank you, Kidzian and Santi Test, for your time. We hope to hear more music soon. Now on to Kitia with the story about our local football team.
Thank you, Santi. Gotham's local football team, Skibidi Toilet, has been doing great this year's season. In the same way, our rival team, Cameraman, from Metropolis, have not been doing so good this year's season.
Yikes. It seems that Skibidi Toilet's defense is so good, even the flush can escape. Am I right?
The rivalry between both teams dates decades ago. Rumors say both cities have been rivals since Batman and Superman's admirers started comparing them against each other on which one was better. Of course, Batman's better. We don't even know the start date of this rivalry yet. We know that how Skibidi Toys have been kicking angles side this season. Moving over, we decided to compare Skibidi Toilet this season to Cameraman to show how Skibidi Toilets clearly are better and are the GOATs. For this, our research team collected the data of football season scores from the years 2025 to 2005 for both Skibidi Toilets and Cameraman's football team. This way we'll be able to compare them both efficiently and accurately.
I heard our research team was so very happy about collecting the data of 20 seasons, or in other words, collecting 680 regular football season scores for both Skibidi Toilets teams and the Cameraman.
Yikes. Our team must have been very tired after this one. I wonder if they were crying of joy again, of course. With the collected data, we created 2 beautiful histograms and 2 box plots, one for Skibidi Toilet and the other for Cameraman, to compare both distributions with each other. As we can see, the distribution of Skibidi Toilet's football 2025 to 2005 season scores is roughly skewed left. Unemoto at 20 to 25 scores has 1 outlier at 56 scores and has no gaps, while the distribution of Cameraman football 2025 to 2005 season scores is roughly symmetrical. Unemoto at 20 to 25 scores and has 4 outliers at 54, 55, 56, and 59 scores. Also, no gaps. Looks like Cameraman tried to shoot their shot, but the lens cap was still on. Moving forward, we can observe how the distribution of Skibidi Toilet football 2025 to 2005 season scores and the distribution of Cameraman football 2025 to 2005 season scores have an equal center at 24 scores. On the other hand, the distribution of Skibidi Toilet's football 2025 to 2005 season scores has a larger spread of 15 scores than the distribution of Cameraman football 2025 season scores with a spread of only 14 scores. Wait, it seems like we're getting more intel at SSM station. Another call has been made from no other than the coach of Skibidi Toilets. I'm excited to hear about this one. Moving over to Santi with the details.
The head coach of my personal favorite football team, the Skibidi Toilets, called the news station to figure out if there is evidence that their rivals, the cameraman, is better than them using points per game. To prove this theory, we first need to select the number of game scores 1 to 307, then use random int 1 to 307 to randomly select 30 games, ignoring repeats, then get the average number of points of these 30 games from the Skibidi Toilets. Now to Kitty with those numbers.
The randomly selected numbers were 7, 35, 13, 42, 20, 42, 42, 30, 9, 47, 41, 23, 33, 33, 34, 13, 28, 20, 10, then 10 again, 24, 31, 12, 30, 32, 13, 33, 26, 45, and 20.
These 30 randomly selected games had a mean of 25.33 points, with a standard deviation of 11.63 points and an N of 30 games. Additionally, we have to do the same with their rivals, the cameraman. We number off their games from 1 to 364, and then use random int 1 to 364 to randomly select 30 games, and then get the average amount of points from these 30 games. Now on to Kitya with those 30 randomly selected games.
The randomly selected scores are the following: 19, 37, 21, 22, 21, 34, 10, 29, 17, 9, 27, 37, 34, 20, 23, 34, again, 28, 22, 16, 39, 24, 13, 35, 20, 35, 31, 3, 27, 24, 10, and 38. And 14. My bad.
Thank you, Kitsa, for those 30 numbers. Their mean is 23.3 points. They have a standard deviation of 9.73 points and an N of 30. Now that we have the means, standard deviations, and N of these two teams, we now have to run a two-sample t-test to figure if there is evidence that one team is better than the other. We first define the sample as mu of Skibidi Toilet minus mu of Cameraman, which is equal to true difference in means of the points in 30 Skibidi Toilet games and the mean points in 30 Cameraman games. The hypothesis is mu of Skibidi Toilet minus mu of Cameraman equals 0, and the alternative is mu of Skibidi Toilet minus mu of Cameraman does not equal 0. Now that we have done the first part, now onto the checks of these samples. Checks. Randomization. Yes. 2 independent random samples. 10% condition. Yes. 30 is less than 10% of all Skibidi Toilet games, and 30 is also less than 10% of all Cameraman games. Now onto large enough. Yes. 30 is greater than or equal to 307, and 30 is greater than or equal to 364. So by CLT, the true difference in means of the points in 30 Skibidi Toilet games and the mean points in 30 Cameraman games can be modeled approximately normal. Since my checks for inference have been met, I can now run a two-sample t-test. These checks were all met in this instance, and now that we have the checks done, we can now go into the calculations. The skeleton formula of a two-sample t-test is t equals x bar of s minus x bar of Cameraman minus 0 over the square root of s of Skibidi Toilet squared over the n of s plus the standard deviation of Cameraman squared over n of Cameraman. Now that we have the skeleton formula, we can now plug in the numbers and get our p-value. We put 0.506 equals 25.33 minus 23.93 minus 0 over the square root of 11.63 to the power of 2 over 30 plus 9.73 to the square root of 2 over 30. We put this into our calculator and get degrees of freedom to be 56.24, and our p-value is 0.61. Now that we have all of our calculations done, we can now state a conclusion on the question. Since my p-value of 0.61 is greater than my significance level of alpha equals 0.05, I will fail to reject my null, meaning there's not convincing evidence that the true difference in means of the points in 30 Skibidi total games and the mean points in 30 cameraman games is not equal to 0. Now let's go into both teams, as based on my two sample t-tests, they are both equally matched for each other, which makes it even more interesting, as they are rivals. I can't wait to see how their rivalry evolves in the future. This concludes this segment. Now to Kitsia with an important segment on Gotham, which might affect how you see this not so quiet city.
Damn it, I really thought Skibidi toys were gonna be way better than Cameraman. I mean, we're in Gotham. Everything about this city is like way more cooler than Metropolis. Skibidi toys are way better than Cameraman. But I guess it's good to dream. Gotham has been losing plenty of money throughout the years. This has caused a local concern amongst Gotham citizens and has raised the question of, why does Gotham continue to lose money throughout the years? Society blames villains such as the Joker, the Riddler, and other villains from Gotham. On the other hand, multiple researchers believe that there could be a possible association between the number of corrupt politicians in office and the amount of money in Gotham City. To investigate this, if it's confirmed that there is an association between both, our research team decided to collect the data of the amount of corrupt politicians in office throughout the years and register the amount of money lost in Gotham City. I'm sure our research team was way more happy about this one. With the collected data, we created a scatter plot and a residual plot to be able to investigate the possible associations between both. The scatter plot and the residual plot will be...
Wow!
When we look at both the scatter plot and the residual plot, there appears to be a strong R of 0.94 positive linear association between the number of corrupt politicians in office and the amount of money lost in Gotham City in thousands, with no unusual points. In this case, since our explanatory variable will be the number of corrupt politicians in office and our response variable will be the amount of money lost in Gotham City, our least squares regression line equation will look something like this. Moving over, by looking at R squared from our scatter plot, 88.3 of the variation and the amount of money lost in Gotham City and thousands can be explained by the approximate linear relationship with the number of corrupt politicians in office. If we continue to look at our association least squares regression line, we can observe how for every one politician increase in the number of corrupt politicians in office, our model predicts an average increase of 0.968 thousandths in the amount of money lost in Gotham City in thousands. If we continue to look at our least square regression line equation, it demonstrates how for a number of corrupt politicians with an office value of 0, our model predicts an amount of money lost in Gotham City worth of negative 5.452 thousandths. Clearly, there is an association between both variables. To double confirm this, we will continue this analysis over to Santi to more information on the topic.
Wowzers, that's a lot of corrupt politicians. Thanks, Kitsia. I'll take over from here. Since we have already defined the variables we need, we're going to run a t-test for beta with degrees of freedom is n minus 2, which is 18. First, we will define beta as beta equals the true slope of the population least square regression line for the number of corrupt politicians in office and the amount of money lost in Gotham City in thousands. Then we will say our hypothesis as our null is beta equals 0, and our alternative is b does not equal 0. Now that we have that, we will now run the checks for linear regression, which is linear. Yes, the scatter plot seems linear, and the residual plot doesn't have a curved pattern. Independence. Yes, 20 is less than 10% of all corrupt politicians in Gotham. Normal. Yes, The dot plot of the residual does not look skewed or have any outliers. Equal SD. Yes. The residual plot doesn't show any Christmas tree or patterns. Memorization. No. But there is no reason to believe that the selected corrupt politicians from Gotham don't represent all corrupt politicians in Gotham. As check is not satisfied, we will continue with caution. And since my checks for inference have been met, I can run a t-test for beta with degrees of freedom 18. Now that we have the conditions done, we'll now run a test with the skeleton formula being t times n minus 2 equals beta minus 0 divided by the standard error times slope. We will now plug in our numbers and get t of 18 equals 0.967 minus 0 over 0.083, which is equal to 11.651. To get our p-value, we need to do t CDF, which is t equals 11.651, infinity, which is 100, and our degrees of freedom, which is 18. And we get our p-value of 8.104 times 10 to the power negative 10. Since we have our calculations needed, we'll now, since my p-value of 8.104 times 10 to the power negative 10 is less than my significance level of alpha equals 0.05, I will reject my null, meaning there is convincing evidence that the true slope of population risk regression line for the number of corrupt politicians in office and the amount of money lost in Gotham in thousands is not equal to 0. Thus, there is an association between the number of corrupt politicians in office and the amount of money lost in Gotham City. As seen in the test, corrupt politicians are very dangerous for the city of Gotham. As the city is so powerful, corrupt politicians are a weak point and need to be brought to justice. That's all for this segment.
So this is all for the special, Skibidis, the year in review. It was a good run. I hope you really learn a lot. I'm very happy to have made this newscast for you. Me, Katia Trejo, my co-host Santi, and our co-host Gus. That's our favorite. I hope y'all give him a warm welcome.
Love that guy.
So, moving backwards with our earlier competition, if you remember, we were trying to figure out the amount of times we said Skibidi during this newscast. So, if you guess the 3 following numbers, please call below. 18, 21, and 22. If you guess one of those 3 correct numbers, please call below to claim your prize. Thank you so much for having us this year.
And also remember, don't be sad that it's ending, be happy that it happened.
You know?